Now you're going to have an acid-base reaction, and what would be the salt that would be produced? It's going to be KOBr. Remember how all salts are produced. All salts are produced in this way that, for example, if you have HCl, the H gets knocked out and the metal takes its place and it becomes NaCl or any salt. Or if you have ethanoic acid or an organic acid, the H gets knocked out and the metal takes its place, so you get a salt. Now HOBr is going to act in exactly the same way. If you have HOBr, the H is going to get knocked out, and in this case, it's potassium. Potassium is going to take its place. So it's going to be K plus 1, and OBr was minus 1. So which is why the salt that is going to be produced is going to be this salt over here. So there's this reaction that's happening that I've written down the equation for that reaction. So in this case, um, first thing you have to figure out what type of mixture is formed at the end of the reaction. So our first goal is let the reaction happen. What does the mixture at the end contain? I mean, because he's asking for the pH of the solution that is produced. We need to figure out what is produced. Let me rub this off first. So 1 second. So we need to figure out what is actually produced in the reaction. Now KOH, you have the moles and you have the concentration, the volume and concentration. So you can find the moles of KOH, which is 5 into 0.2 divided by 1,000. So let's do that. It's going to be 5 times, what was it? 5 times 0.2 divided by 1,000. N is equal to C into V. 5 into 0.2 and divided by 1,000. So it's 0.001 moles. So the moles of KOH that you have are 0.001. They're 0.001 moles. Similarly, you need to find the moles of this HOBr. You're given 20 cm cube and the concentration is 0.2 mole per dm cube. So that's going to be 20 times 0.2 and whatever it's going to be divided by 1,000. So you get 0.004 moles. So now the first thing is, one of them is in excess. Which one specifically is in excess? This is in excess. Because 0.001 is going to react with just 0.001 moles. It's 1:1. The equation suggests that they're going to react in 1:1. So 0.001 moles is going to react with just 0.001 moles. So that means 0.003 moles of HOBr would be left unreacted. I mean, they're not going to take part in the reaction. So they would be left unreacted. So that's the first thing. So 1 second, they would be left unreacted. Is this clear so far? Sarah, is this clear? Aisha? Abu Rera, is this clear?
Yes.
Yes, sir.
And 0.001 moles is going to react with 0.001 moles to produce its 1:1. So the salt that would be produced would be 0.001 moles.
सर बड़ा लंबा चौड़ा क्वेश्चन है, कितने मार्क्स का है ये?
सिर्फ 2 marks.
सिर्फ 2 marks?
हाँ बस इसी तरह सॉल्व होगा. That's the only way you can solve this. ठीक है, there's no shortcut. I mean, you do get questions. It's only 2 marks. I mean, this is kind of, sometimes it's for 4 marks. 2 marks is like 2 less for this. Okay, because the problem is that you have to figure out the mixture at the end. And for that, you have to go through all this calculation. You have to figure out what's left at the end. Okay, if you can't figure out, you can't solve the question. So 2 marks is just too little for this, all this working. At the end of the day, what's the mixture? Mixture at the end. Okay, the final mixture. Now we can find pH if we know what the mixture is at the end. So the mixture at the end is you have a salt. So you have 0.001 moles of the salt. And the other thing that you have is the unreacted acid. You have 0.003 moles of acid. So it's a buffer solution. If you have a weak acid and a salt, the salt is the conjugate base. If you have a weak acid and the salt, they form a buffer. What is the formula for a buffer solution? It's Ka is equal to salt concentration into H plus 1 concentration divided by the acid concentration. So the K value was given initially in the last part. The K was given right over here. It was given as 2 times 10 power minus 9. Somebody try and solve this. My calculator would definitely not solve this. 2 into 10 power minus 9. And it would be salt concentration is 0.001 divided by 0.003, which is the acid concentration. Remember, you can directly input moles because if you use concentration, concentration would be moles over volume. Moles over volume. The volume term would automatically get cancelled out. So no need to actually calculate concentration because then that's an extra added step into H plus 1 concentration. So can anyone, Sarah, can you try and find what the H plus 1 concentration is? And find the pH as well.
6 into 10 power minus 9 H plus 1 इसकी pH होगी
6 times 10 power minus 9. Sarah, are you getting the same question? Aisha, did you try this?
Yes, yes,
Okay.
sir 8.2 pH
yes.
So it's 8.2. Acha, we can let me also quickly open like because it's a very long. I mean, this question requires a lot of working and it's just 2 marks. So it's W19 QB41. Let me quickly also open the marking scheme W19. Just 1 second. No, it's sorry. Just 1 second. Let me open Google. So this is which question? What was the question number? It was question number 5. So question number 5 in the marking scheme. Yeah, I mean, they did the whole entire. I mean, why is this for 2 marks? That's a huge question. I mean, it's like you're doing so many calculations. There are 4 steps. Even in the mark scheme, he's actually he's doing 4 calculations first. Then there are 2 more calculations also. I mean, just for 2 marks, that's not justified. Okay, but usually it's a 4 mark question, not a 2 mark question. So, anyways, moving forward, let's try and solve this question. You have ammonium chloride, which dissolves. As the last one, is that clear for everyone? Aisha, is this clear? Abu Rera, clear tha? Sarah?
yes sir
So the next one is you're given ammonium chloride and it dissolves in water to form an acidic solution. This is due to the dissociation of ammonium ions. So this is behaving as a weak acid. It's the same equation. Ha breaks down, produces H plus 1 ion and some other ion. Okay, we don't ignore even the charge on this A. I mean, just some other thing. So it's the same weak acid. Now, ammonium ion is a weak acid. I've already told you the pH is of a 0.3 mole per dm cube solution of ammonium chloride is 4.89 under standard condition. The first step is you need to find the H plus 1 concentration. So you have the pH. The pH is given as 4.89. Quickly solve this. Tell me what is H plus 1. H plus 1 would be, I mean, this is negative log of H plus 1, that's 4.89. So if you make H plus 1 the subject of the equation and take anti-log, it's going to be 10 to the power minus 4.89. What's the value? Yeah, I can't actually do powers in this. What is the value that we're getting?
Is it 1.29 times 10 to the power negative 5?
1.29 times. It looks fine. 10 to the power negative 5. Abu Rana, sahi? Now, the other one is, I said, now you're being asked to calculate the pK value. Basically, you first have to calculate the Ka value. I mean, what is Ka? Ka is, and this is not a buffer solution, it's just a weak acid. So the formula that you're going to use is H plus 1 squared divided by the acid concentration. I mean, you don't need to derive the whole thing again. H plus 1 squared into acid divided by acid concentration. So H plus 1 is there. You have H plus 1, it's 1.29 times 10 to the power minus 5. And that's obviously squared divided by the acid concentration. What is the acid concentration? They've given you 0.3 mole per dm cube of ammonium. This over here is 0.3 mole per decimeter cube. That's provided. First, try and find K, and pK would be the negative log of that value, K. Do this calculation, tell me what the answer is.
9.25.
9.25. हो सकता है. Sarah, did you try this? Aisha? क्या आंसर है?
The Ka or the pH?
PK.
Is it? I got different answer. Wait, a negative log?
Yeah, I mean, you take for whenever you say PK, that means the negative log of K.
Okay.
Aisha, आपने किए?
So I got minus 10.7.
Minus कितना?
10.7.
ये minus पे तो नहीं होना चाहिए. It's, let me try this. 1.29.
I got it now. Yes, it's 1.3. 1.3.
So everyone is probably getting a different answer.
So मेरा 9.25 है.
I think, I suspect it's probably 9.25. Can anyone do the calculation again? It's
Yes, it's 9.25. Yes,
okay,
but I rounded.
I said okay, that's fine. I thought 1.3.
Okay.
I thought you were saying 1.3. So it's 9.25, and that is probably the correct. Actually, I just wanted to check whether did we get the right answer 8.2 for the last question. Yeah, we got 8.2. So you can remember if something has a lot of steps, there are lots of chances of making silly mistakes. So like the previous question. It had a lot of steps. Now, this one is a buffer solution can be made by mixing ammonium chloride with ammonia solution. Explain with the aid of an equation how the solution can behave as a buffer when a small amount of strong acid is added. So, ammonium ions would be in equilibrium with, they're going to dissociate to produce NH3 and H plus 1. Where would the equilibrium shift if you add more H plus 1 ions? If you try to add more H plus 1 ions, if you try to increase the concentration of H plus 1 ions, the equilibrium would immediately shift to the left. So the quantity of H plus 1 would remain unchanged. You try to increase H plus 1, so it's simple Lee-Shatler principle that if you try to increase H plus 1, it's going to try and decrease H plus 1 ions, and the equilibrium would shift to the left. So you're going to write that equation when a small amount of strong acid is added. So write the equation in the backward direction. So what you're going to write is H plus 1 would react with NH3 to produce NH4 plus 1 ions. That is going to be your equation that you're going to write for 1 mark. The next one is explain with the aid of an equation the opposite. It's when a small amount of base is added. Now, when you're adding a base, so I'm going to do the working on the same equation. Where would the equilibrium shift when you add a base? Now, the first thing the base would do is the base would the base has OH ions. So the base would neutralize the H plus 1. The OH ions and the H plus 1, the OH ions would immediately go in, they would start reacting with H plus 1 ions to form water. This is the reaction that would start to happen. So this is the reaction that's going to start to happen as soon as you add OH minus 1. And if H plus 1 concentration decreases, Lee-Shatler principle suggests that the equilibrium would shift to the right hand side. And it's going to try and produce more H plus 1 ions. So I'm going to repeat this. As soon as you add OH ions, the H plus 1 would get neutralized and they would form water. And this equilibrium over here would shift to the right because there would be fewer H plus 1 ions. So it's going to try and make more H plus 1 ions. So more ammonium ions are going to dissociate and the quantity of H plus 1 would be maintained in this way. So you have to write the overall reaction. So you have to write the equation in the forward direction. So you got to write the equation in the forward direction. It's going to be NH4 plus 1. Moving in the forward direction to form NH3 plus H plus 1. Now remember that the H plus 1 ions are getting neutralized. Who's neutralizing them? It's OH ions. So you need to add OH ions as well. What's happening is that the OH ions are coming in and they're reacting with the H plus 1 and then neutralizing them to water molecules. So you have to alter the forward reaction just a little bit to add in the OH ions and their effect and to show their effect. So this would be your equation in the forward direction. Okay, remember this is how you write the equation in the forward direction. And this could apply to any weak acid. So always mention the OH ions. Is this clear? Aisha, is this clear? Sarah, Aburera, is this clear?
Yes, sir.
Yes, sir.
Then the next one is use the value. Is this a continuation? Probably not. Use the value. Wait, something is wrong. Is it a continuation? Did he give us the value of? No. So it's basically it has nothing to do with the previous part. So C part 1. Use the value of Kw. Now this is given in the data booklet, but you have to remember this as well. You can't open the data booklet always. So Kw is given as Kw has this expression. It's H plus 1 concentration into OH minus 1 concentration. It's the ionic product of water. When water ionizes, it produces 2 ions, which is H plus 1, and the other one is OH minus 1 ions. Now, you already know what the H plus 1 ions are actually. You know that the concentration in pure water under standard conditions is 1 into 10 to the minus 7. mole per dm cube. Very few H+1 ions, and the quantity of OH ions is also exactly the same. But he's asking us to actually show the working. I mean, we know this as a fact. I mean, we know what the answer is, but he has specifically stated show the working. How did you get this? Like from Kw value. The Kw value is 1 times 10 power minus 14. I mean, this expression could be written as because both of the ions in pure water would be present in the same quantity. So you can write this as H+1 squared. And you can show your working that you're underrooting this and underrooting this to get this. So you're going to get 1 times 10 power minus 7. The next one is, this just 1 second. So the next part is, now remember one thing, that this water, the ionization of water that we are discussing over here, this is only true under standard conditions, which is 25 degrees centigrade and 1 atmospheric pressure. This is C, and that's it probably. Under standard conditions. Remember this, that water, if temperature increases, there's more ionization. Like molecules bump into each other more, and there are going to be more ions produced. So the value of Kw is actually going to be significantly higher. Not significantly higher, just slightly higher. Because more water molecules are going to ionize, and the concentration of H+1 and the concentration of OH ions, it's going to be greater. So more ions are going to be produced. Now, they are talking about 50 degrees centigrade, and they're asking calculate the numerical value of Kw at this temperature. So first thing, they've given you the pH, which is 6.64. You can figure out, try and calculate, tell me what the answer is. That the pH is 6.64. So what is H+1 concentration at 50? It would be 10 raised to the power minus 6.64. What's the value that you're getting?
2.29 times 10 to the power negative 7.
So it's 2.29 times 10 power negative 7, and that's mole per dm cube. Okay. Remember, I mean, so it's 2.29. So it's clearly, I mean, there's more dissociation happening. I mean, previously at 25 degrees centigrade under standard conditions, the concentration of H+1 was actually slightly lesser. Now it's double that amount. It was 1 times 10 power minus 7. Now it's 2.29 times 10 power minus 7. What would be the concentration of OH ions then? It's going to be the same. Because if it's pure water, if it's pure water, it's going to ionize and it's going to produce equal amount of ions. So if this many H+1 ions are produced, this many OH ions would also be produced. So now try and find the Kw value at 50. At 50, Kw is H+1 concentration multiplied by OH ion concentration. So it's basically 2.29 times 10 power minus 7, and you need to square that. What are we getting? Abu Sarah, Aisha?
Is it 5.24 times 10 to the power negative 14?
5.24 times 10 power negative 14, that's the value.
You got it.
And the unit for Kw is, remember, mole squared dm minus 6. It's basically concentration, but remember, don't forget the unit. It's concentration multiplied by concentration. Then let's do another question. This one. Now this question over here, this is something I've explained earlier as well. That if you have a diprotic acid, where did I explain this? 1 second. I probably explained it over here. Like I told you that if you have phosphoric acid, which is a triprotic acid, remember that the acid is going to produce, in total, it's going to produce 3 H plus 1 ions, but it's not going to behave as one acid. What would happen is it's going to release an H plus 1 ions initially, like it has 3 OH groups, so it's going to release an H plus 1 ions initially. Then after releasing the first H plus 1 ions, this ion that is formed, it's going to release another H plus 1 ion. So that's the second dissociation, and that's the second Ka value. And the third one would be then at the end you're left with this ion, and it's going to release another H plus 1 ion, and it's going to form these 2 ions. And that's your third dissociation constant. So diprotic or triprotic acids that can produce more than one H plus 1 ion, they have multiple dissociation constants. And the first dissociation constant is going to have the highest value, because it's very hard for this ion to, like, if this ion is formed, it's a negative ion. It would be attracting the H plus 1 back again. It's very hard for it to actually lose another H plus 1 ion. So the greater the negative charge on the ion, the lesser would be the chances of H plus 1 dissociating. So fewer and fewer H plus 1 ions are going to be produced the third time. So just hold on 1 second. So we just finished this question. We were talking about this thing that if you have a triprotic acid, it's going to dissociate, and there would be 3 different Ka values. So if you go back to the question, this should be Ka1. This is the first. So this is the first dissociation. Anyways, they're asking for the expression for the second dissociation, so it's going to be H plus 1 concentration. This one into SO4 minus 2 concentration and divided by the acid concentration, which in this case would be HSO4 minus 1. Okay, so that's stage 2. And then they're saying H2SO4 is considered a strong acid, whereas HSO4 minus 1 is considered a weak acid. And I told you that it's a weak acid. Why? Because of the negative charge. Negative ions would in fact be attracting H plus 1. They won't be releasing H plus 1 ions, which is why they're considered weak acids. They're very bad acids. So any negative ion, it's not going to be a good acid. So it suggests how the magnitude of the acid dissociation constant for stage 1 would compare to. So stage 1, there's going to be more dissociation. More products would be formed, more H plus 1 ions would be formed, which means the value of Ka would be, you're going to have a higher Ka value. So you can write that in this part over here in part 2. Okay, is this clear? Aisha, is this clear? Sara, is this clear? Abu Rera?
Yes, sir.
Yes, sir.
So then you have that benzoic acid is a weak acid, and the pH is given. You're supposed to calculate the value of Ka. So for a weak acid, the formula is H plus 1 squared. So we can do this very quickly. Divided by the acid concentration, and the pH is already provided. So it would be, I mean, we can do this directly. It would be 10 power minus 2.9. I mean, you can do the working over here. Minus log of h plus 1 is 2.9. So h plus 1 would be 10 power minus 2.9. And that's squared. Divided by the acid concentration, which is already given over here. It's benzoic acid 0.0250 mole per decimeter cube. Tell me what the value is.
(6.3 into 10 power minus 5).
You get 6.3. 10 power minus 5? Okay.
Yes.
So it's 6.3 times 10 power minus 5. So we'll at least try and solve 19 and 20 paper, year 19 and year 20 questions. We're going to continue tomorrow then. Okay, any questions? Aisha, clear hai? Burera, is this clear? Sarah?
Yes, sir.
Yes, sir.
Okay then, take care.
Okay, sir. Okay, Allah Hafiz.
Allah Hafiz, sir.